In this video, I will show you how to write the equation of a hyperbola whose graph is given to you, and we'll find all this information as well. So the first thing you should write down is the center of the hyperbola. This problem is going to be extra easy because the center is just 0, 0. The next thing you need to pay attention to is whether or not the hyperbola is horizontal or vertical. And when I say that, I'm just talking about what they call the transverse axis. Or if I draw a segment connecting the vertices, see how that's horizontal? So I'm considering this to be a horizontal hyperbola. When the transverse axis is horizontal, and they seem to want us to write that down, that tells me that the x term is going to be the first term in the equation. So normally I would have like x minus h squared, and then I will have y minus k squared, and it's always going to equal 1. But since the center is 0, 0, h and k are 0, so we won't have minus h or minus k. So it'll just be x squared and y squared in the numerators. Again, I knew that the x squared would be first because it is horizontal. Now all we need is the a squared and the b squared. The a value is the distance from the center to a vertex. So you can see here that my a value is 6, which means that a squared is 36. So this is my denominator. Take note that this is horizontal, so it makes sense that the 36 will go in the denominator of the x term. Okay. Now, what about the b value? We need the denominator of the y squared term. We need the b squared. To find that, we're going to need the rectangle. So let's go ahead and draw in the missing rectangle. So we know that the sides of the rectangle have to pass through these vertices, and they have to touch the asymptotes. The asymptotes go right through the corner of the rectangle. So if I start to draw my rectangle right through these vertices, and I keep drawing them until they reach the asymptotes, bam, they hit the asymptote here and here. Okay, if I do the same thing on the left side, it's going to hit the asymptotes here and here. So that's it for these sides of the rectangle. Now all I have to do is draw my way across the top and the bottom, and you've got your rectangle. So notice how the asymptotes are the diagonals of the rectangle. That's how I knew to stop right here. Now I can see what the b value is going to be, because the b value is going to be the distance from the center to a covertex. That's going to be the side of the rectangle where there is no branch. So that is 6. Oh, okay, that's the same thing. So the b value is 6, just like the a value was 6. That's interesting. So the b squared is going to be 36 as well. So I'm going to have another 36 denominator. Okay, so a and b are both 6. We still need to find the c value. Just remember that c squared is equal to a squared plus b squared. So c squared is going to equal 36 plus 36. So c squared is going to equal 72. So c will equal the square root of 72. Now, of course, this 72 is 36 times 2. All right, that's where we got it from. So to simplify this, it'll be 6 root 2. So c is 6 root 2. Okay, they don't seem to be asking us for the foci, so we don't have to worry about that. So all we need, we just need the equation of the asymptotes. So remember, you can use point-slope form, and if you choose the center of the hyperbola, the model will be y minus k is equal to plus or minus m times x minus h. So the h and k, that's just the center. Well, remember, the center was 0, 0. So I'm just going to put 0 in for h and k. So all we really need is the slope now. Well, this seems to be going up 1 over 1. Or you could think of it as up 6 over 6. Either way, it simplifies down to 1. So the slope is just going to be 1. So substituting all those values in, I have y equals plus or minus x. All right, let's do one more. So for number 10, we need to know, we need to take a good look at the center. So the center is right here. I'm having trouble. All right, I guess this is the x-axis, so this would be 3, 4. All right, so the center is 3, 4. So let's go ahead and start making the equation of this hyperbola. So I know it's going to be a fraction minus another fraction equal to 1. Because this is a horizontal hyperbola, I know that the x term is going to be first. So I know this is going to be like x minus h squared and then y minus k squared over there. But the h and the k are the 3 and the 4. So let's go ahead and fill that in. So I'm going to do the opposite of these. So I'm going to have minus 3 actually and minus 4. So our numerators are done. All we need is a squared and b squared. Well, that's easy peasy because the a value is the distance from the center to a vertex. So we can see that the a value is 4. So a is 4, which means a squared is 16. So the first denominator, which is always a squared, is 16. Now, the second denominator, the b squared, that's slightly more tricky because we have to draw the rectangle to find it. So we know that the two sides of the rectangle, the vertical sides in this case, will go through these vertices. So let's go ahead and build the sides of the rectangle. We know that the asymptotes have to go right through the corners of the rectangle. So that's why I'm stopping the sides of the rectangle at the vertices, because that's where it must turn to make the horizontal part of the rectangle. All right, again, that's because I know the asymptotes have to go through the corners. They are the diagonals. Well, now I can easily see the b value. The b value is the distance to a covertex, which means the distance to the side of the rectangle that doesn't have a vertex there. So I can now see that the b value is 2, which means that b squared is 4. So that's going to be the other denominator, which is 4. Okay, the transverse axis is horizontal. Okay, when they talk about the transverse axis, they are just talking about the segment connecting the vertices. All right, that yellow I just highlighted, that's the transverse axis. It is horizontal. We already spoke of the a value, which was 4. The b value, which was 2. We can use that to find the c value. So for hyperbolas, we know that c squared is equal to a squared plus b squared. For ellipses, it was minus, but for hyperbolas, it'll be plus. So in this case, c squared will equal 16 plus 4. So that tells me that c squared is equal to 20. So c is equal to the square root of 20. So c is equal to 2 radical 5. You know, because 20 is 4 times 5, so 2 radical 5. So that's what we have to put down for c, is 2 radical 5. So the only thing else they want, the equation of the asymptotes. So look, slope-intercept form, you guys. Here's a model that will always give you the equation of the asymptotes. I'm going to say y minus k is equal to plus or minus m times x minus h. This is just the point slope form of a line. But the point I'm using is the center of the ellipse. That's why I said h and k, because h comma k is always the center. So look at this 3 and 4. If I substitute the 3 and the 4 in for h and k, the 4 is the k. So I'm going to wind up with y minus 4 equals. And then I have plus or minus. Now the m, that's the slope. So look at one of the asymptotes. Look at the box as you do this and ask yourself, what's the rise and the run? So, por ejemplo, this goes up 2 and over 4. So the slope is 2 over 4, which of course simplifies down to 1/2. So that's why I'm going to have plus or minus 1/2 right now. And finally, the x minus h part. This is the x part of the equation, so I look at the x coordinate of the center, and I put x minus 3. So that's it. This one equation represents both asymptotes because of the plus or minus. The plus represents the upward sloping asymptote, and the minus represents the downward sloping asymptote. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.